Hi, physical science students. Ms. Schuler here, and we're going to be talking about how to measure using proper measuring tools, and we'll also learn how to do metric conversions. So the first measurement we're going to talk about is measuring length. Remember, that's a straight line distance between 2 points. And our proper measuring tool for measuring length is the meter stick. And we're going to look at 2 examples here. We'll do one together, and then you'll try it. And we're going to be measuring the length of a die. Now, what you'll notice here is we have our meter stick, and you'll see that our die is lined up with the 0 centimeter marking. This is a very common mistake that a lot of people make. They'll want to align their object with the edge of the meter stick, and if that's not where the 0 centimeter marking is, you'll notice that we'll have this dead space that would mess up, right, our measurement. So again, line up the object with the 0 centimeter marking, and then we read from left to right. We see that our die is at least 1 centimeter, right? We can pass that there, but it doesn't quite reach the 2 centimeter marking. So our die, we would say, is 1 centimeter, but this is measured to the nearest tenth. Tenth means having 1 decimal place. So we'll say 1 point. And then what we're going to do is count off. You'll notice in between 1 centimeter and 2 centimeters, there's 10 little markings. Those markings, those 10 markings, represent the location of this 10th place. All right. So all we have to do is count how many little markings we have. So if we go left to right, we see we have, this would be 0.1, 0.2, 0.3, 0.4. 0.5 is a little bit bigger, and it kind of helps you count these lines a little bit faster. But you'll notice we're 1 little line after. So that would be 1.6. We remember what we said, all right, always tack on a unit, no naked numbers. We just measured this in units of centimeters. So again, you're going to try the tack. Look, make sure you look, you'll see that the tack is aligned at the 0 centimeter marking. So now you're going to read what that measurement is. All right, next we're going to talk about measuring using a graduated cylinder. And a graduated cylinder measures the volume, right, of a liquid. Remember, volume is the amount of space taken up by a liquid. So you'll notice our graduated cylinder shows us that we're measuring in units of milliliters. And we are going to read from the bottom up. So you'll notice that when we put a liquid inside a graduated cylinder, in order to read it, you have to get eye level to the surface level of the water. Now, when you do this, though, you'll actually notice a little curve, and that curve is called the meniscus. And this is because water has this fascinating property in which it sticks to the sides or the walls of an object. Now, when you read a graduated cylinder, you want to find that meniscus, your eye level, but you're going to read the bottom of the meniscus. And what we're going to do, like we said, is work from the bottom up. We see that we have a 60 milliliter marking here. We have a 70 milliliter marking up here. So we're definitely at 60, but we are not at 70. So what we can do is measure each little marking. And you'll notice that if I'm going from 60 to 70 and there's 1 little mark, 10 marks in between, that each of these marks represent 1. So when we read this, we see that this is 60, 61, 62, 63, 64, 65, 66, and this would be 67. Okay, so we would label this as 67. Okay. And double check our units. This is a graduated cylinder. It's measuring in milliliters. All right. Now, here's another graduated cylinder for you to try. And remember, when we do this in person, we'll do this in person in our metric measurement lab. You always want to get eye level and read from the bottom up. Okay, again, this is in milliliters, but go ahead and give this one a shot. What would the milliliter measurement for this graduated cylinder be? All right, now, next, we have a scale, and this is pretty straightforward, but there are some things I want you to take into account. So our scales are just going to give us the measurements right on the digital screen. Now, we have to be careful, though. The scale should read 0 before anything's placed on it. So if it's an empty scale, it should read 0. Okay, remember, scales measure the mass of an object, which is how much matter or stuff it is made out of. And if you have nothing on the scale, it should read 0. Now, if it doesn't say 0, but there's nothing on it, what you're going to need to do is 0 the scale by clicking on the 0 button. Okay, so each scale will say tar, or it'll say 0, and it'll 0 it out for you. So at that point, if it's empty, it should then read 0. You also want to double check the units on the scale. Some scales are able to measure in different types of units. If it says grams, you're good. We'll measure in grams. If it says ounces, there is a button to be able to change the units on the scale. And then if it says grams, if it says 0 before you place anything on it, then you can simply place your object on the scale and record that measurement on the screen. All right, the next thing we're going to talk about is how to practice converting from one metric measurement to a different unit within that same metric system. So let's go ahead, and what I'm going to have you do is you should have a piece of loose leaf paper, and you should label this FCM metric conversions. All right, we're going to do problem 1 together, and what I'm going to then have you do is try number 2. But let's go ahead and we'll do number 1 together. As I write out these steps on the board, you should be also copying them down on your paper. So it says convert 25.2 centimeters to meters. That means we're going to start with 25.2 centimeters. All right, and then it says we want units of meters. If we don't want centimeters, centimeters needs to be on the bottom. And it says we want units of meters, so that's going to go up top. Then we have to think about, what do we know about the prefix centi? Remember, centi means 100, okay? So we have to ask ourselves, where does 100 go in our factor? Does it make sense to put 100 up top and say that 100 meter sticks fit into 1 centimeter? No, that doesn't make sense, right? But we can say that 100 centimeters fit into 1 meter. So 100 is going to go on the bottom. We'll put 1 meter up top. Centimeters and centimeters cancel. We have the unit we want. Notice that we want to end up with meters. So multiply it out. 25.2 times 1 is 25.2. Our unit is meters. On the bottom, we have 100 and no units. They canceled out. And now we can just plug this in our calculator. If we have 25.2 meters divided by 100, that would be equal to 0.252. No naked numbers. We notice our unit is meters. All right. So I'm going to have you try number 2 on your loose leaf. And then when you feel like you got it, hit play and you can check. So for number 2, we have 60.5 milliliters. And you'll notice that we want to convert it to liters. So if we do not want milliliters, we're going to multiply by a factor that has milliliters on the bottom. But we want units of liters. But we know something about milliliters and liters, so we can do that. When we think of milli, we think of thousand, right? We have to ask ourselves, where does 1,000 go in this factor? Well, I like to visualize it. Remember, a liter is like a liter bottle, like a bottle of pop. And milliliter is like a few droplets. So is it going to make sense that 1,000 liter bottles are the equivalent to one or a few droplings? Well, that doesn't make sense. It does make sense, however, that 1 liter bottle would hold thousands of droplets. Okay, so 1,000 is going to go on the bottom here. Our units will cancel. Milliliters and milliliters will cancel. We're left with the unit liters, and that's what we want, so we can multiply it out. We'll put our equal sign. We'll multiply the top numbers, 60.5 liters. Liters didn't cancel. On the bottom, we have 1,000. No units on the bottom, though. You'll notice that those canceled out. So then we can do 60.5 divided by 1,000, and that would be 0.0605. All right, and our unit is liters. So that tells us that 60.5 milliliters is the same as 0.0605 liters. All right, now we'll go ahead and do number 3 together. And number 3, you'll actually notice, has 2 prefixes, centi and milli. So when we have 2 prefixes in a problem, we'll actually have to take a pit stop at our base unit. So the very first thing we're going to do is go from centi to meters. We'll get rid of that centi first, And then we'll go from meters to millimeters, adding on that milli prefix. So let's see what that looks like. We'll do 5.6 centimeters. And remember, we don't want centimeters, so we're going to multiply by a factor and put centimeters on the bottom. So we're not going to go straight from centimeters to millimeters. We can go from centimeters to our base unit of meters. We can ask ourselves, well, how do I go from centimeters to meters? When I think of centi, what do I think of? Well, that would be 100. And we can ask ourselves, where would this go in this factor? Does it make sense to say 100 meter sticks fit into a centimeter? No, that doesn't make sense. But it does make sense to say that 100 centimeters fit into 1 meter stick. So centimeters now cancel and we're left with meters. But we want to go to millimeters, so we're going to multiply by another factor. We'll get rid of meters by putting it on the bottom, and we can convert that to now millimeters. So the next step is to think, what does milli mean? Remember, milli means 1,000. So does it make sense that there are 1,000 millimeters in 1 meter? Or 1,000 meter sticks fit into 1 millimeter? Well, for us, it's going to make sense that 1 meter stick holds 1,000 millimeters. Meters and meters cancel. We're left with the unit of millimeters, and that's what we want here. We want millimeters, and that's how we know that we're done, and we can multiply it out. So we're going to multiply the top numbers. 5.6 times 1,000 is 5600. Our unit up top is millimeters. Our bottom number is 100. And if we put that into our calculator, we see that that would be 56 millimeters. So 5.6 centimeters is the same as 56 millimeters. Now, if you want to try number 4 on your own, go ahead and pause that video, try it, and then hit play, and we'll see how you did. For number 4, you'll actually notice that, again, we have 2 prefixes. We're going to go from milligrams to kilograms. So if we have 2 prefixes in there, we're going to have to take a pit stop at just grams. So we're going to go with 157.6 milligrams. And if we don't want milligrams, that's going to go on the bottom. So in this step, we're getting rid of milli, and we're going to try to get back to that base of grams. Remember, milli means 1,000, okay? So we have to ask ourselves, does it make sense that 1,000 grams fit in 1 milligram? No, that doesn't make sense. There are actually 1,000 milligrams in 1 gram. All right, remember, a milli is really small. I need 1,000 of those small pieces to equal 1 gram. Milli and milligram cancel. We're left with grams. Now we have to go one step farther, though, because we really want kilograms. So if we want to get rid of grams, grams is going to go on the bottom. Kilograms can go up top. Remember, kilograms is like 1,000. Kilo means 1,000. Remember, kilograms are like dumbbells. Grams are like paper clips. Is it going to make sense to say 1,000 dumbbells or 1,000 kilograms equal 1 paper clip? No, that doesn't make sense. Now, what does make sense is we say 1,000 grams or 1,000 paper clips would be equal to 1 kilogram or 1 dumbbell. So grams and grams cancel. We're left with kilograms. That's the unit we want, so we can do our equal sign, and we can multiply it out. Here, our top number is 157.6. Our unit is kilograms. Over, when I multiply 1,000 by 1,000, that's a number with 6 zeros at the end. All right. And when we divide by that, already we have to move it over 6 places. So 1, 2, 3, 4, 5, 6. That would be 0.000157.6 kilograms. You can always put that in your calculator if you want. But that tells us that 157.6 milligrams is the same as 0.0001576 kilograms. And we're going to do a metric activity in which you will be collecting your own measurements and practice converting those.